In finance, the Vasicek model is a mathematical model describing the evolution of interest rates. It is a type of one-factor model as it describes interest rate movements as driven by only one source of market risk. The model can be used in the valuation of interest rate derivatives, and has also been adapted for credit markets, although its use in the credit market is in principle wrong, implying negative probabilities, section 21.1.1. It was introduced in 1977 by Oldřich and registered trademark it for equal or more than ek and can be also seen as a stochastic investment model. Details: the model specifies that the instantaneous interest rate follows the stochastic differential equation, where Wt is a Wiener process under the risk-neutral framework modeling the random market risk factor, in that it models the continuous inflow of randomness into the system. The standard deviation parameter determines the volatility of the interest rate and in a way characterizes the amplitude of the instantaneous randomness in flow. The typical parameters and, together with the initial condition, completely characterize the dynamics, and can be quickly characterized as follows, assuming to be non-negative, long-term mean level. All future trajectories of will evolve around a mean level B in the long run. Speed of reversion characterizes the velocity at which such trajectories will regroup around in time. Instantaneous volatility measures instant by instant the amplitude of randomness entering the system. Higher implies more randomness. The following derived quantity is also of interest: long-term variance. All future trajectories of will regroup around the long-term mean with such variance after a long time, and tend to oppose each other. Increases the amount of randomness entering the system, but at the same time increasing amounts to increasing the speed at which the system will stabilize statistically around the long-term mean with a corridor of variance determined also by. This is clear when looking at the long-term variance, which increases with but decreases with. This model is an Ornsteiner-Uhlenbeck stochastic process. Making the long-term mean stochastic to another SDE is a simplified version of the cointelation SDE. Discussion: Vasicek's model was the first one to capture mean reversion, an essential characteristic of the interest rate that sets it apart from other financial prices. Thus, as opposed to stock prices for instance, interest rates cannot rise indefinitely. This is because at very high levels they would hamper economic activity, prompting a decrease in interest rates. Similarly, interest rates cannot decrease below zero. As a result, interest rates move in a limited range, showing a tendency to revert to a long-run value. The drift factor represents the expected instantaneous change in the interest rate at time t. The parameter B represents the long-run equilibrium value towards which the interest rate reverts. Indeed, in the absence of shocks, the interest rate remains constant when Rt equals B. The parameter A, governing the speed of adjustment, needs to be positive to ensure stability around the long-term value. For example, when Rt is below B, the drift term becomes positive for positive A, generating a tendency for the interest rate to move upwards. The main disadvantage is that, under Vasicek's model, it is theoretically possible for the interest rate to become negative, an undesirable feature. This shortcoming was fixed in the Coxa-Ingersoll-Russ model, exponential Vasicek model, Blacker-Dermani-Toy model and Blacker-Karaszynski model, among many others. The Vasicek model was further extended in the Haller-White model. The Vasicek model is also a canonical example of the affine term structure model, along with the Coxa-Ingersoll-Russ model. Asymptotic mean and variance. We solve the stochastic differential equation to obtain. Using similar techniques as applied to the Ornsteiner-Uhlenbeck stochastic process, this has mean and variance. Consequently, we have and. See also, Ornsteiner-Uhlenbeck process. Haller-White model, Coxa-Ingersoll-Russ model, references. Hull, John C. Options, Futures and Other Derivatives. Upper Saddle River, New Jersey, Prentice Hall. ISBN A0-13-009056-5. Vasicek, Oldřich. An Equilibrium Characterization of the Term Structure. Journal of Financial Economics 5, 177 Euro 188 doi, 10.1016/0304-405 times opening round bracket 77 closing round bracket 90016-2 Damiano Brigo, Fabio Mercurio. Interest rate models are Euro theory and practice with SMILE, inflation and credit. Springer Verlag. ISBN A978-3-540-22149-4, Jessica James, Nick Webber. Interest rate modeling. Wiley. ISBN A0-471-97523-0. External links, price of zero coupon bond under Vasicek model, free online calculator, QuantCalc, the Vasicek model, JRN Iraka, Wisconsin School of Business, yield curve estimation and prediction with the Vasicek model, D. Bazit, Middle East Technical University.